Hi, this is a quick video about the MS70 CDR. So I had this a little while ago. I got some money from my company a while ago for being a good boy, and I kept hold of it and bought one of these, and it came with version 2.1 of the firmware and a fair amount of FX. Now, the problem is, of course, I want to computer control it, and the next problem is, well, what can it do? So if we scroll down through the official documentation, tap tempo, that's great, 6 effects, fantastic. 86 guitar and bass, well, I don't know about that, it seems to have more, maybe I'm wrong. 40 preset patches, that's right. Tuner, yep. Tap tempo, yep. Little 1/4-inch jacks for stereo. Some people say that not all the effects are stereo, runs on battery, so 7 hours, okay, great. What else do we see here? Okay, that's great, but where's the list of what's on the pedal, yeah? Okay, so if you go into their, I don't know where you find the actual, I think you go to support and downloads and then you have to look all over again, yeah? Here we are. Effects list. Okay, let's look at the effects list. Yeah, the operation is okay, but it's a bit non-intuitive. It takes a while for me to get used to it. So I want the computer control. So now we can see it's got, maybe I can make that bigger. How do I do that? Control plus. Yeah, I don't know what the little blue star means. Who knows? But you see now you've got things like tremolo, gyro trem, etc., and you've got all the values like 0 to 100 and this sort of stuff. So that's all very well and good. But I now want to computerize this, and I don't really want to have to type all this in. So what I've done is in the downloads directory, I put the firmware, and now we can use a standard Unix command, strings of Zoom, and we can look for ZDLs. So, okay, we've got a starting point. So this gives us a list of possible ZDLs. Now, I suppose we could also not look for C, beginning of the line C colon. Okay. And we could also not look for slash dot out. Okay, and then we could put that into word count minus L. And this should be 86 according to the documentation. 909. Well, phew. Wait a minute. Okay, so we could pipe that into pipe that into unique, and then pipe that into word count minus L. 139. Yeah, I think that's more reasonable. I think there's more than 86 effects. So I could use this as a starting place to work out what's on the pedal, yeah. But then I remembered I was doing some work on this pedal in the past on my DOS computer, and I moved the stuff into the ZoomPedalFun, and I've just merged it in now. So under the ZoomPedalFun, if I can find that. Oh, wait a minute, I shouldn't have done that. This seems to kill the Raspberry Pi. I think I'll be killing that. Hang on. Let's try. Oh no, actually it's the Pi 4. It's okay on there. It's on the Pi 3 that Chromium kills it. Good old Mr. Putin, what a wanker. Let's now have a look at where we're looking for. Zoom pedal fun. Okay. And I just checked this in this afternoon. I was at work having done a training course, giving a training course, and then all the power went off, which was handy. So I can't work. But I can work at home, so I will log in a minute. Okay, so I click on here. Where's it gone? Come on, my son. There we are. And I've just added in this MS70 CDR. And the reason you see it like this is there's nothing in the intermediate directories. So in 2.1, which is the firmware, you'll be able to find now, oh, how have I got all this information? Well, I'll show you. I suppose I should count how many ZDLs are in there. And I can do that. Give me a second. So if we now were to cd /software/ZoomPedalFun/MS slash derive data slash 2 2 dot whatever, ls minus L star dot ZDL pipes into word count minus L. So is it 86 or 139? 128. Okay. So I found 128 of them. So somewhere in between. Okay. How did I do it? Well, the code is in there. I was looking through the code of the ZDLs and I was asking Manjo about this for, he has we both have the modern zooms, but these ones use the ZDL, and the ZD2 or ZT2 rather is in ZD2, get it right, is in fact like Zoom DL version 2. And what I was asking is, do we know where they get the ID from in a ZDL? And then I found it myself, is that if you look inside 64 characters plus 8, then you can begin to find that's where the ZDL comes from, a split, yeah. And this, sorry, let's go back to main. So this gets fed in from main. Here we go. So what you do is you download your own copy of the firmware. argv2. Why do I need 2? argv1. RB. So that the first argument therefore is the file to read, okay? And we're looking for this pattern here, which represents the 6 past the start of a ZDL, okay? So we read that in, close the file, create a byte array, and then we walk along this size -8 because we already had 8 bytes in. Because we're checking 8 bytes here, and we check that we've got this beginning signature at the beginning. Then we walk it, and this is based on some stuff that Barsic did. So what he found is that there are 2 blocks of 3, 6 bytes in total, that are used as length markers in blocks, and each block on a Zoom pedal is 4096 bytes. So you get 4090 because you lose 6, and that's how many you get in a block, and it tells you the next block, next block, next block until you get a -1, and then you end that block, and then you move to the next block. Okay, so this checks that we're moving blocks at a time, and there we are. 4096 is the next block. So I'm reading this from memory because I did this a few months ago and forgot I did it, yeah. And then we go the checks, and if the next block is -1, then we've finished. Otherwise, we carry on, and we check the file name, which is returned from check ZDL. So basically, when we get to the next block as -1, then we read the block, we concatenate it into our raw, and then we pass that ZDL into check. So now we look at check, and what does check do? Makes good beer. That's what the checks do. And they're very nice people. Anyway, so we've passed the ZDL in. Now we know we've got to start at 8 bytes on from the 64th byte for 8 bytes. And we look for the on-offs. If we don't find it, if we find an on-off because it's not -1, then we know we're starting a block. We know that 48 bytes or 30 hex is the size of it. And somehow I worked out this is where you can get the FX name and the FX ID from. And then you can also find out if it's got parameters and the max MIDI and the min MIDI and the name, yeah? So then I also found out if you've got a pedal parameter or not, depending on the values inside it. And then I create a JSON file and write it out as fxname.zdl. So that's basically what this code does. And you run process firmware, and somewhere up here I think I've got a check me as well. Let's look in here. Oh, let's just check this one a second. Was this the one that didn't have the concept of the blocks? There's the CS split, and that used to split files into certain sizes. Yeah, this is how, okay, this was the old way I did it. The old way I did it was I said, oh, look, a ZDL is based on this split. And this goes wrong because the block has this 4096 per block, 4096 bytes per block, and the 6 bytes for determining the size of the next block, or if you hit the end of the blockchain. Yeah, so this is where you need to read what Barsic did. So this is there for historical reasons. This is the code that it uses, and check me here. What does he do? This is an individual one, I think. So check me is for an individual file, and the process firmware is for the whole firmware. So yeah, here I think you're supposed to put in a ZDL. So use the process firmware, and when you do that, let's have a quick look at our list again. So Tremolo, let's put that to one side. Come on, you can do it. Now put that to one side. And where is there a pi thing there? We're in the right directory. ls trem star. Yep, so vim tremolo.json. What do I think it is? I think it's got an ID of 8 and 6, and I need to check this myself actually. This could be useful. I think it's version 1. I think it's got a depth. It has. I think it's 0 to 100. I think 80 is the standard one. I also think it's got a rate. I think 78 is the max. That says 0 to 50, so I don't understand that. I'll have to check that. I think 150 is the max for that. And page 2, level. Oh, sorry, that's the wave level. Yeah, 150, sorry, that's right. 130 is the default. And the wave has got 29, of which 21. So I would have to somehow work out this up, down, up, down. But these are the MIDI values, yeah? Let's look at the dual tremolo. Yeah. Vim duo. Oh, I've got to put it on the screen. Duo trem.json. So I think a duo tem has got those values. I think it's got a rate A. There we are. I think it's 70. Again, that says 50, and I think 78. I don't know why I think that. Maybe because I'm a moron, or maybe they're lying to us. I think rate B has also got this weird number. Yeah, I'm gonna have to check that. I think there's a mistake there. 150, that's correct. DPTA, there we see it. DPTB, yeah, 0 to 100. And this is all derived from reading the firmware. I haven't. So in the past, with the G5N, I think it was, I had to physically read this in because I couldn't get the data out. But with the later, slightly later pedals, the 70 CDR, you can get the values. So this will be my basis for knowing what the effect names are. I'll be checking in the firmware to see if I can find in the decode if I can see these numbers somehow encoded. And just to give you a file example, so that's how I've pulled the firmware apart. It's in the GitHub now, so you can get it if you want it, and ping me on the issues if you think something's different. Now what I'm doing is I'm writing, and this isn't checked in yet. So I've got various things that allow me to get the current patch, yeah. So here the magic number is 61 for these pedals, yeah. So this is pretty standard Zoom stuff. 29 is get current patch, 61 is the ID, and from here I can run things like get more data, which basically flushes the buffer, get the current patch, unpack it with my C program because my current patch stores it in get current patch stores in current patch.bin. I can then let me have a quick look for a second. Hang on. Yeah, I'm not quite used to the API on this thing, yeah. I think I'm on the first parameter now. So I could, for example, say fxmpn shell 1, parameter 1, and I'll set that to 0. And that's gone to -10 on the display, yeah. Now if I run that get more data, whatever, then I can see the output here is OA28, okay? Now what I can do is I can set it to 10, which will put it to 0 on the display. And I can run that again. And I begin to see that now it says 4A, yeah? 4A01, in fact. So 18.020 4A01, and it was 80.20 OA. So it's gone to, so what it says at this top this nibble here and that nibble there are the 8 bits at least 8 bits that are being used to process. Now, I don't know, maybe it's 12 bits, who knows, yeah, because Zoom often does 12 bits, but I know there are 9 parameters for this thing. One last thing, I keep saying that, I'm a bad man. So on the Zoom page here, I try and give people credit and I try and allow you to find other people's work because it's a collaboration and it's nice to work with other people. So down here I have this link to, I think it's 200 kg, that's kind of what I want to say. 200 G200 kg. Okay, so this dude or people have done fantastic stuff and they're also working on the MS70. It's a really good program. Okay, but one thing that I find, and they have also discussed some of the MIDI stuff, which I'm looking at here. Yeah, so I appreciate what they've done here. If we look at the MIDI message, for example, they've documented some of it, but there's a bit more to it than what they've said. Yeah, so again, they've said program changes, that I agree. Turn MIDI mode, tuner mode on, I agree, was nice. Identity, yes, that's all standard stuff. What's interesting, I can send the FX, I can send the parameter changes, but I can't send the FX changes. And the way I think that they do it is to write the patch out. So they say it's this 58 is the MS50G, yeah, 61 for our pedal. So you send the 28 and then the effects concatenated together and then an F7, okay? So that's pretty neat. However, what they do is a bit crazy here because if you ever read this stuff, it doesn't seem to make sense. It's like B7, B6. So these are like bit patterns, and as you read through the byte, these values take on different meanings. What it is that they have neglected to unpack the code. So when we look in the MSCD code here, there it is, CPP, get unpack. What you should do is to read the array in, and then you should walk the array, and you don't want the first 5 bytes, and then you need to do this kind of thing like what Manjul did and what I've done in the past on Miniacs or whatever. Read in the byte and keep looking for, push the pipe back if there's no high bit. Otherwise, use the bits of the first byte you read to determine, as you use the bits of the first byte to set the top bit of the next bytes in the chain. And this has the effect of shrinking or packing in many senses of the word the binary. So the standard Sysex you get back from the pedal will now be shrunk by about 7/8, yeah. So it would be about 7/8 the size, roughly speaking. When you do that, changes like what I've just shown you become more apparent, and you're not dicking around with this bit has that bit and that bit and that bit. Now, of course, once you've done that, you then have to push it, expand it back out the other way in order to get back to the format. But let me show you what I mean here. I don't think I'm being very clear here. So this is the raw coming in, like what G200 kg talks about. But what they're not doing, you see you have these bits here that are set. So you can tell where it says empty, yeah? So where's the E? 45. This column here is a bit. So the 4 means that 4 along here needs to have a top bit set in order to give it an 8 byte value in reality, okay? But you can't send 8 bytes apart from the first and the last bit. You can't send the 8th bit down a Sysex, yeah? So this is the unpacked and what the G200kg is talking about. But if you do the process that's in the code I'm going to check in, then you can turn it into its concatenated or pack size, and then these patterns begin to be clear. So I've now successfully decoded the P1 and the P2 and I think P3, and I'm just walking through the other parameters, and then I'll be able to have those set up. These group IDs and things like that. So for example, I think that it says 80 for the first one, yeah, 128, group ID 5. That's what I think it says. Now, if I look on the pedal, it's an SMR, whatever the hell that is. So I don't know if I can find an SMR in here. Is there such a thing? Okay. QBang. So let's just see if we can find grep name in star.json. See if we can find that. FX name. So grep FX name in star.json pipes into grep -I for don't care SNR. No, SN. No. So I don't know what that is yet. I have no idea what effect that is, and I'll have to be working through to see if I can find it. Maybe I can set the ZNR. How do we do that? Monotone. Is there a monotone? Monosynth. So again, there are differences on the pedal with the names they give. Mark B. Is there a Mark B? Come on, there's got to be one of them. No. HRT. Hormone replacement. No. So I don't understand that. Warp phase, let's go down. So those are amp models which it doesn't claim to have, but maybe I'm not able to decode them. Bass metal, bass squeak, scream, bass muff, acoustic. Have we got acoustic in there anywhere? No. Okay. I'll not worry about that. Anyway, that's what I'm doing at the moment. I'm trying to work out what the parameter values are in the compress space, and then once I've got that working, I should be able to read it in and decode the values and start putting it into a GUI. Equally well, if I can correlate these ZDLs with what's on the pedal, and they ought to be because that's where it came from, then I should be able to try and work out if those group IDs make any sense, and then whether they are, some bit shift pattern. So that's really what I wanted to say, is that I've been quite busy on other stuff recently, but there was a power outage today, so what can I do? I can't use the works computers. I'll use mine instead. So okay, thank you for your time, and enjoy. Okay, bye.